Hello, everyone. This is Mr. McMillan, and I'm here with the notes on the introduction to trigonometric ratios. And we're going to start out with a bit of a review or a little bit of an overview, rather, on the Pythagorean theorem and special right triangles. And the reason we're going to do that is because trig is very closely related to those. So first off, we found out that we could determine whether something was a right triangle or not by using the Pythagorean theorem. And the Pythagorean theorem, of course, is a squared plus b squared equals c squared, where a and b are your legs and c is the hypotenuse. Okay? Now, when could you use the Pythagorean theorem? It could always be used when you were given two sides of a right triangle. So either you had both the legs already or you had the hypotenuse and the leg. Okay, so two sides of a right triangle. Now the next thing we talked about were a couple of special cases for right triangles, and these were the 45-45-90 triangle and the 30-60-90 triangle. And so in a 45-45-90 triangle, what gives that away is if you have one angle being equal to 45 degrees. And the good thing about these types of special right triangles is that they could have been used to find the other two sides when only given one side. That was a shortcoming of the Pythagorean theorem. You couldn't necessarily find, another leg or another hypotenuse if you didn't already have two sides of the right triangle. So your triangle properties for 45-45-90 triangles, the legs are congruent and the hypotenuse is equal to the length of the leg times root 2. Okay, now if you're given a leg already, like we've said in other videos, you already know what your other leg is, so all you have to do is take your two legs and use them in the Pythagorean theorem to find your hypotenuse. But this is a shortcut method to find those lengths if you want to. Then next up is your 30-60-90 triangle. And if you remember, they have a short leg, long leg, and hypotenuse. The length of the short leg is half the length of the hypotenuse. So in other words, if you want to find your hypotenuse when you have the short leg, you have to multiply it by 2 to find your hypotenuse. And the long leg is equal to the length of the short leg times root 3. So before we move on to trig and seeing how we can use that in the general sense, let's look at these first two examples. And we're going to see these two examples in our trig examples here in a minute, just so we can compare our methods and see if they're equivalent. So, number one, it says for the triangle below, what is the length of AB and AC? So we're missing AB and AC, and we're given BC. So we're given one of the legs. Okay? And here we see that we have a 45-degree angle. And this 45-degree angle tells us that this is a 45-45-90 triangle. Okay? Now we're given a leg, and we know in a 45-45-90 triangle that the legs are equal. So we already know what the other leg measure is. And so all we have to figure out is whether AB is our other leg or AC is. Well, AB touches the right angle, but AC does not. Since AB touches the right angle, that means it's our other leg, which means AB must be 17. Now, there are two ways to go about this. You can use the shortcut method, which is what I'm going to do, but I'm also going to show you that the Pythagorean theorem would give you the exact same thing. So, if you take your shortcut method, you know that the hypotenuse is equal to the leg times root 2. Our hypotenuse is AC. Our leg is 17, and then we tack on the root 2. So AC is 17 root 2. Now, we're going to use the Pythagorean theorem, okay? So we've got a squared plus b squared equals c squared. We're going to show that we would have gotten 17 root 2 with that as well, even though we're going to write it in a decimal form. So a and b are your legs. They're both 17. So 17 squared plus 17 squared equals c squared. And if you take, in your calculator, 17 squared, you end up with 289. And if you double that, because they're the same, you get 578 is equal to c squared. Now, in order to get rid of the squared that's on the c, because remember, we just want c, we don't want c squared, we need to do the opposite of squaring a number, which is square rooting it. And when we square root 578, we get 24.042 is C. And if we go, I'm going to go into Desmos because it's a little bit easier. Okay. If my computer will cooperate with me. And I'm going to type in 17 root 2. And we see that we get the exact same decimal, 24.042. Okay. All right. Number 2, for the triangle below, what is the length of OM and ON? And we see here that we have a 30, 60, 90 triangle. And we're given the length of the hypotenuse. Okay. Now, we want to find our short leg first. So we're going to take our formula, which is the hypotenuse is equal to 2 times the short leg. Our hypotenuse is 6. Our short leg is OM because it's opposite the 30-degree angle. And we get that OM is equal to 3. All right. Then we want to find our long leg. And if we want to use the formulas, I'm just going to use the formula. You can use the Pythagorean theorem. So the long leg is equal to the short leg times root 3. So that ends up giving you that ON would be equal to 3 root 3. And if you set up your Pythagorean theorem, you would end up with 3 squared plus b squared equals 6 squared. You'd have 9 plus b squared equals 36. And then you'd subtract 9 and get b squared. B squared equals 27. And then square root both sides. And if you look, if you plug that into Desmos, those would be the exact same things. We'll come back to these in a minute because we're going to use trig later on to see if our results are identical to what we have. And I will tell you for reference that this decimal is approximately 5.2. All right. Now let's look at how we set up our right triangle trig. So we're going to consider the following diagram of a right triangle ABC with angle theta. And theta is just a Greek letter. Okay, it's this symbol here. So anytime you see that, it's read as theta, and it typically just takes the place of an angle. So what we're going to do is take note of the sides that are opposite and adjacent to theta. Well, first we have to figure out where theta is. And in our diagram, we see that theta is located at angle A. So theta is located at angle A. This is our starting point. Okay, this is our point of view. This is what we're going to be basing everything on. Now, the first thing we want to figure out when we do our sides is what our hypotenuse is. That's the first thing we're going to try and find out. So in this diagram, what side would be our hypotenuse? And if you looked at this picture and you answered that AB would be your hypotenuse, you would be correct, because AB is opposite of that right angle. So AB is our hypotenuse. All right. Now we're going to look at the side that's opposite of theta. Now we're going to look at our side that's opposite theta. Well, similar to how we just drew an arrow here, our theta, which side would be opposite of theta? Would it be BC or would it be AC? Well, BC does not touch theta at all, so that means that it is opposite of theta. So we would say BC is opposite of theta. And I'm going to write it on here just to be sure. And finally, that leaves AC to be our adjacent side. And the reason this is adjacent to theta is because it is touching that angle A there. Now, what's important to note, although the hypotenuse is adjacent to theta, we only say that the leg is adjacent. Okay, so only the legs are opposite or adjacent. The hypotenuse is always just the hypotenuse. Okay. Now, this is where a little bit of the confusion comes in. If we are labeling these to help us do our work, what we want to do is use O, H, and A. We're not going to be using A, B, C when we use trig. And that's going to confuse a lot of people. But for trig, that's going to just be one of those things you'll have to get used to. We're going to label them with O, H, and A. And the reason why we do that is because we're just shortening hypotenuse, opposite, and adjacent. So opposite just becomes O. Adjacent becomes A. And hypotenuse becomes H. And you'll see why we do that here in just a second. All right, so next up, we want to use the sides of the right triangle to set up trigonometric ratios. Okay, we're going to talk about 3 ratios in this class. These are the 3 basic trig ratios. Okay, so we have an identical graph to what we had up here. So we said that BA was our hypotenuse, H. BC was our opposite side, and AC was our adjacent side. So the first one we're going to talk about is sine. And sine, the way we write it, we write SIN, parentheses, theta. And we say that that's equal to the opposite side divided by the hypotenuse. The opposite side divided by the hypotenuse. And using our abbreviations, that would be O over H. Now, if we had links for these sides for O and H, we would just plug in the numbers here. I'm going to write the side links that they would be. So it would be BC divided by AB. That would be your sine of theta. And whenever you write those as a fraction, you need to make sure that you simplify those fractions completely. And remember, you can do that in Desmos. All right. Next up is cosine. Cosine, we do, we write COS, parentheses theta, and cosine is adjacent over hypotenuse. So adjacent over hypotenuse, which would be A over H. So our side lengths would be AC over AB. And finally, our tangent. We write our tangent as TAN, parentheses theta, and that's equal to our opposite side over our adjacent side. So that's O over A, which in this case would be BC over AC. All right, so a good way to remember the trigonometric ratios is to use the following memory device. Okay, so to use the following memory device, and we can use, what we use is SOHCAHTOA. So we just put that all together, and it's divided into 3 parts. Now, something that there's a bunch of sayings that go for this. You can look up the sayings if you want to for SOHCAHTOA. I discussed one of them in class. Okay, so but just know that you're taking each letter from SOHCAHTOA, and it stands for something. So first off, SOHCAHTOA, that means the S stands for sine, and that's equal to O over H. Next up is CAH, which is CAH. So C stands for cosine, and that's equal to A over H. And then finally, TOA, you have tangent is equal to O over A. It's important that you make sure that you get these patterns down, patterns memorized, and know when to use them. Okay? Now, before we move on, I want to make sure that your calculator in Desmos is in degrees. So go to Desmos. And in Desmos, you, if you're on the Virginia Standards of Learning version, you'll see it like this. I want you to click this wrench up in the top right. And your, the bottom here should look exactly like mine. And the reason this is important is because we mostly work in degrees. Okay, so if radians, if yours looks like this here with the radians boxed in and colored in, you need to change it to degrees. That will change your answer significantly if you do not do that. Okay. All right. So let's look at some examples here. And the first one here, or the first couple, for problems 1 and 2, it wants you to find the value of each trig ratio in the following triangles for the given angle. And it wants us to write our answer as a simplified fraction. So on the first part, we have angle D. Now, angle D is the angle that it wants us to look at. So anytime it wants you to figure out the sine, cosine, or tangent of a certain angle, you're going to put your theta on that angle. So in this case, we're going to put theta on angle D. Now we have our 3 sides, which are 6, 8, and 10. The first one we're going to identify is our hypotenuse. So which side is our hypotenuse? Well, that should be 10 It's opposite the right angle, but it's also the largest side. So we know that 10 has to be h. Then we're going to put our opposite in, or we're going to label our opposite side, excuse me. And our opposite side is the one that does not touch theta. So which one does not touch theta? Is it 6 or is it 8? And the answer is it is 6. So we would put an O on 6 for opposite, and our 8 is A for adjacent. So now that we have O, H, and A labels here, now we can find what our sine, cosine, and tangent are. So sine, our pattern, so remember SOHCAHTOA, SOHCAHTOA. So SOHCAHTOA, your sine is associated with your opposite over your hypotenuse. So O over H. And we said that O is 6 and H is 10. Now it wants our answer as a simplified fraction. So what you can do is you go into Desmos. And in Desmos, you're going to type in 6 divided by 10. And it's going to give you this decimal 0.6. Now, we want it in the most simplified version. So what we're going to do is we're going to click this little fraction bar inside a circle here, and it will simplify that decimal to its simplest fraction form. So we're going to click that, and it turns 0.6 into 3 over 5, and that's our simplest fraction. Okay? So 6 over 10 is equal to 3 over 5. And you can do that for any of these problems here. Next up is cosine. Cosine is the C-A-H. So we have A over H is cosine. Our A is 8 over our H, which is 10. 8 over 10, if you plug that into Desmos and simplify, you'll find that that's equal to 4 over 5. And finally, tangent of D. You have tangent of D will be O over A. And O over A, your opposite is 6. Your adjacent is 8. And if you simplify this in the calculator, you end up with 3 over 4. So what I'd like you to do now, I want you to pause the video and try number 2. All right, so number two, we have angle X. And what we want to do here is we want to put our theta where on the angle that it's asking for. So in this case, it's on angle X. So our theta, angle X. And we're going to label our hypotenuse first. And our hypotenuse is 29. Our opposite side, would it be 20 or 21? Well, 21 does not touch theta, so 21 has to be our opposite side. That means that 20 is our adjacent side. So sine is defined as opposite over hypotenuse. So in this case, it's 21 over 29. And if you were to plug that into Desmos, you'll see that 21 over 29 is already in its simplest form. So we just leave it as is. Next is cosine of X. So cosine of X, we have adjacent over hypotenuse. Our adjacent side is 20 over our hypotenuse of 29. And again, that's in our simplest form. And then finally, tangent of X. tangent of x is O over A, and O over A is 21 over 20, which does not simplify either. So make sure that you simplify those completely, because if you if you answered it on the quiz test or whatever else, they always want it in simplest form. All right, so for problems 3 and 4, it wants us to determine the value of each trigonometric ratio for the given angle using your calculator. And it wants us to round to 4 decimal places. So we're going to go to Desmos, and our first one that we're wanting to use is theta equals 1. Okay, so we're wanting to find the sine, cosine, and tangent of a 1-degree angle. This is why we needed our calculator to be in degree mode. So what we're going to do is we're going to click this keypad down here, and we're going to go over to functions. And when we click functions, it brings up a trig menu first. And the trig menu, on the very left side, you'll see sine, cosine, and tangent. So we're going to click sine first, and then we're going to put 1. And then we're going to round this decimal to 4 places. So sine of 1 degree is equal to 0.017. And then the 4 has a 5 following it, so we're going to round up to 0.0175. Then we're going to do the same thing for cosine of 1. So we're going to go back, we're going to hit functions, hit cosine, and then type in 1. And that gives us 0.9998. And then finally, tangent of 1, which is 0.0175. You can try number 4 on your own with the sine of 59, cosine of 59, and tangent of 59. And I'll be back with those values in just a minute. All right, so if we're doing the other ones here for number 4, we had sine of 59, which is 0.8572. We round up the 1 because it has a 6 following it. Then we do cosine of 59, which is 0.5150. And then we do tangent of 59, which is 1.6643. The reason that I had you do this is because it's important to know how to use the calculator in order to find your sine, cosine, and trig values, because we are going to be using those all throughout this trig section, okay? All right, so next up, it says for problems 5 through 8, determine the value of the missing sides using trigonometric ratios. For problems 5 and 6, compare these answers to the answers for examples 1 and 2 on the first page. Round your answer to the nearest tenth. So what we're going to do, we're only going to do 5 and 6. 7 and 8 will be in tomorrow's video, along with some other example problems that we do together in class. All right, so number 5, it says, what is the length of AB and AC? And the important thing here is we want to put our theta where our angle that is not a right angle is. So the angle that's not a right angle is our 45-degree angle, so we're going to put theta there. Next up, we're going to label what we know with either an O, H, or an A based on where it's at. So we know that we have a 17 here, and that 17 does not touch the does not touch theta, so we're going to put an O on it because it's opposite. Then we can label our H and A. AC is our H because it's opposite of the right angle, which leaves AB, our other leg, to be adjacent. Now, what we need to do is set up equations to find our missing sides. So what I'm going to do, I'm going to find the adjacent side first. Now, this is a 45, 45, 90 triangle, so I would expect my two legs to be equal. So we're going to work through this trig in order to see if that's true. So our two legs are O and A, so we have to use the trig function that deals with O and A. And the trig function that deals with O and A is tangent. So we're going to write tangent, and then in the parentheses, we're going to put our angle, which is 45. Tangent is defined as O over A, so O is 17, divided by A, which is just A. And now we can find these. Now, I did this a little bit differently in class, so I'm going to show you, and I'll show them later. But we're going to use cross multiplication here to solve this. Okay. So here, I can say that this is the same thing as tangent of 45 over 1. And now we have two fractions equal to one another. So if we cross multiply, the first thing we're going to cross multiply is the A and the tangent of 45. So we get A times the tangent of 45 equals, and then 1 times 17. Now, as you saw when we were plugging these into the calculator, tangent of 45 is just a number. So I need to get A by itself. So to get rid of tangent of 45, I just divide both sides by tangent of 45. So I get A equals, and then you plug in what 17 over tangent of 45 is. So if we go to our calculator here, we get 17 divided by tangent of 45, and that gives us 17. So that means that our adjacent side is 17, and that's exactly what we expected to happen. We said that these legs should be equal because it's a 45, 45, 90 triangle. And it turned out that that was true. All right, next up, we're going to try to find our hypotenuse. Now, we did find the adjacent side, but I'm not going to use my adjacent side just in case I made a math mistake. Okay, so I'm going to go back to the original thing it gave me, which is 17, which is our opposite side. And the trig function that uses O and H is sine. So we're going to have sine of 45, and sine is defined as O over H. So sine of 45, our O is 17, and we don't know what H is. We're going to put the sine of 45 over 1, and then we're going to cross multiply. So we get H times sine of 45 is equal to 17. And then we divide both sides by sine of 45. And if you plug that into Desmos, you get that H is approximately equal to, and I'm just going to replace tangent with sine. And you get that H equals 24.0. And if we look back at our problems initially, we can see that we ended up with the exact same answers. Okay, so the trig functions are ways that we can do these. The ways that we can do these without having to know the shortcuts. All right, so likewise, we're going to do number 6. And then call it for this video. So 30 degrees here is our theta. And the side that it gives us is MN, which is 6. And MN is our hypotenuse. So that's our H. And now we label with O and A. So our opposite side is the one that does not touch, which is OM. And our adjacent side is the one that does touch, which is ON. Now in this case, I want to find what my opposite side is first. So here, my opposite side, and I also have my hypotenuse. So the trig function that uses O and H is sine. So we have sine of 30. And sine is defined as the opposite over the hypotenuse. So the opposite is O. And our hypotenuse is 6. So we're going to put sine of 30 over 1, and we're going to cross multiply. Well, 1 times O is just O. And then we have 6 times sine of 30. So O is a variable. It's by itself. So all we're going to do is plug in 6 times sine of 30. And if we do that, we get 6 sine of 30, which is just 3. So O equals 3. All right, then we want to find A. Again, we're going to focus on using our H, which is what was given to us before. So what trig function uses A and H? That would be cosine. So cosine of 30 equals A over H. So we don't know A, but we do know H is 6. We're going to put cosine of 30 over 1, and we're going to cross multiply. So we're going to multiply A and 1, which is just A. And then we multiply 6 and cosine 30, which is 6 times cosine of 30. And if you plug that into your calculator, you get that 6 times cosine of 30 is 5.2, approximately. And if we go and look at our initial ones here, we see that we had 3 and 3 root 3, and the 3 root 3 ended up being 5.2, which is exactly what we got here. So that shows you that trig is the way you can do this if you desire. Okay. Most people prefer to use trig once they learn how to do it and learn how to set up the equation and everything else, because it makes more sense to them. As always, you know, with the special right triangles, you can use either method, but trig is pretty consistent in everything else. Tomorrow we will talk, in the next video, we will talk about number 7 and 8 on here. And we're going to do the same process, but this time we have different values than 45 or 30 or 60. So we need to make sure we use trig on these. Trig is not optional for those. All right, guys, that's it for me in this video. Make sure that you work on IXL R.1 to a score of 50. If you have any questions about any of the material, please contact me or Mr. Thompson, and we'll be more than happy to help you out as best we can. Thanks, guys, and I will see you in the next video.